Hello. Let's start chapter 6. Chapter 6. The title of this chapter is Sampling Distribution. Before we start this chapter, I would like that you think in these two words. What do you think is sampling distribution? What is your expectation in this chapter? What do you think we are going to study? Try to think about it. Sampling distribution. Okay, first of all, let's start with the definition of these two parameters that you know, parameter and a statistic. Parameter is related to population, a statistic is related to sample. A parameter is a numerical descriptive measure of a population. Because it is based on observation in the population, its value is almost always unknown. A sample statistic is a numerical descriptive measure of a sample. It is calculated from the observation in the sample. Actually, there are a lot of parameters and statistics, but the most important parameter in one data or population are the mean, median, variance, standard deviation, and proportion, binomial proportion. We use a Greek letters to denote this parameter. And for each parameter, we have a corresponding statistic. To denote the statistic, we use Latin letters like this. Actually, everybody knows it's possible that we are going to focus in this, in the next 4 chapters, in these two parameters, the mean and proportion. Actually, this is our target parameter, but we are going to use the samples mean and sample proportion to estimate this parameter. The concept of sampling distribution. Actually, sampling distribution of a statistic is a probability distribution for all possible value of the statistic computed from a sample of size n. What is the meaning of that? If we have a population, in this population we have members, then if we decided to do one study about one parameter of this population, we are going to select one sample, and in this sample we are going to measure this statistic. Suppose that we have a sample of this size. Actually, we want to know if we are going to select one sample of this size, sample of size n, we are interested in knowing what is the distribution of all possible samples mean obtained from sample of size n, but to study that, we need to obtain all possible samples or a large number of samples of the same size, all of them. Then we need to compute the mean for all of them. The mean for all of these samples. And so on. Actually, the sampling distribution consists in the distribution of all of these values, x1, x2, x3, all of these values. Actually, the sampling distribution of the sample mean, because we can obtain sampling distribution for variance, for mean, for mode, for standard deviation, for whatever parameter, statistic. But let's start with the sampling distribution of the sample mean. X bar is the probability distribution of all possible value of the random variable X bar computed from a sample of size n from the population with mean mu and standard deviation sigma. How can we do that? First of all, we need to obtain the first sample of this size n, and we compute the mean for this sample. And after that, we continue taking sample of the same size, all of them of the size n, and compute the corresponding samples mean. Actually, the idea is to obtain all possible samples of the same size to analyze how those data are distributed, how those samples mean are distributed. For example, the weight of penny minted after 1982 are approximately normally distributed, with mean 2.46 grams and standard deviation 0.02 grams. Actually, that is the distribution for individual values. Each penny, the weight of each penny is represented by X. Then we can organize all penny in the United States in this pile according to its weight. All penny that weigh 2.5 grams will be stocked exactly in this column. All penny that weigh exactly 2.48 will be stocked in this column. And actually, when we finish organizing all of these penny of the United States, we will observe the shape of this pile. The shape of this pile will be normal, will be a mound shape. Most of the, actually, there are a high column of penny that weigh exactly the mean. Listen, but now we are interested not in the sampling distribution for individual value, but the sampling distribution for all possible samples mean when my sample size is n. When the sample size is n, we are interested in X bar if we want to analyze the sampling distribution for the mean, or this standard deviation, sample standard deviation, if we are interested in the distribution for the standard deviation. Let's focus only in the mean, and we need to take all possible samples of the same size and compute our parameter in which, or our statistic in which we are interested. When we have all of this value, then we organize all of this value, and we are going to determine how is the distribution. We need to find the mean, the standard deviation, and what is the shape. Let's do this procedure not for all possible samples of size 5, but for 200 samples. From all penny in the United States, we are going to select 200 samples, all of them size 5. And let's analyze what happened with the distribution of all of these samples, all of these values. Actually, when we select the first sample, suppose that this is the first sample, we weight all penny. We have 5 penny. 1, 2, 3, 4, 5 penny. Then the mean of these 5 penny will be 2.44. We sum all of them and divide it by 5. Actually, this will be my first samples mean among these 200 samples that we are going to obtain. Then, listen, this will be the first one. In this table, we have 100 samples mean. That was the first one that we obtained in my first sample. And this is the sample number 100. Is equal the mean of this sample, the sample number 100, when we sum and divide it by 5 the weight of all of this penny, we obtain this number. Actually, here in this other table, we have 100 more. In total, we have 200 sample size 5. Actually, the standard deviation, the mean of this distribution, when we analyze all of this value, when we compute for all of this value, the mean, actually, if we want to compute the mean of all means, actually, let's assume that this is a population. But it's not a population, it's only 200. But the mean of all of this value will be obtained adding all of these samples, means, and divided by 200, in this case, n. And the standard deviation, actually, we use this symbol in statistics, we use the mean of all means. And actually here we use the standard deviation for all of this value. The standard deviation for all x bar is given, we have to use the same formula that we used before, the sum of each mean here minus the mean of the population, the square, divided by n, because it's population. Let's assume that this is a population. When we apply these two formulas, we can obtain these two values. The mean for this 200 is 2.46, which is the same mean of the population. And the standard deviation is 0.086, which is smaller than the standard deviation of the population. It's a little smaller. No, it's smaller. Actually, let's analyze the histogram. That is the histogram for this 200 sample, size 5. Actually, the shape of this sample is pretty normal. And we obtain from this 200 sample a mean equal to 146 and a standard deviation 0.0086. But only for 200 samples. If we obtain all possible samples of size 5, all of them, actually we can obtain one distribution like this. Here we have all possible sample of size 5, and the shape of this distribution is like this. Actually, this is the distribution for all samples mean, not for individual values. Here, 1 point will represent one sample. And here is the mean. This value here will be the mean of this sample. We have a question here. The impact of sample size on sampling variability. What is the effect of the sample size in the variability of the sampling distribution? Okay, let's analyze if we increase our sample size from 5 to 20 to see what happened. Actually, what is the most important measure of variability in any data? The most important measure of variability in quantitative data is the standard deviation. Then we expect when we increase the sample size, the standard deviation or variability will be different. Ajá. ¿A qué huele? ¿A qué? ¿A qué huele? Yo no siento ningún olor.
¿O tú calentaste una comida?
Yo calenté una comida.
Eso fue. Estamos esperando que Solón está vuelta a llegar a las 7.
Llega a las 7, estoy aprovechando para grabar las clases.
Entonces lo que huele es eso, como un queso quemado.
Lili, no me hagas eso porque estoy grabando las clases.
Entonces, ¿qué bajo la luz?
Sí, pero el sonido de los carros me pueden también afectar.
Oh, mierda. Pero ya estás grabando.
Ah, no, apenas empecé.
Pero, para un momentito mientras yo...
No, ya lo paré, apenas sentí la puerta, ya lo paré.
Pero entonces, dame un chance para que dame 2 minutitos, si quieres. No, el olor de queso quemado, no sé qué, pecueca. Es eso.
Me cogí, fue un... Eso con queso, sí. Es un Alfredo, chicken Alfredo.
¿El queso o parmesano? Parmesano quemado.
Ay, no, paré, man.